We're going to review how you use Desmos to help you with normal curves. Make sure, though, to get credit, since I'm letting you guys use normal curves, you're going to have to sketch the curve in shade and also give the z-score. You're going to have to calculate that by hand, but it's simple. Okay, so question 13 gives us an average college credit card debt for college seniors and then the standard deviation. Anytime you see these words normally distributed, just let it trigger. We're going to use a normal curve. So on Desmos, if you guys open up Desmos and you start typing in the word normal dist, and see how it's italicized? As soon as you do that, it turns into up and down. Parentheses, you want to put the mean, comma, standard deviation. Mean, comma, standard deviation. 3262 and 1100. 3262, comma, 1100. And then hit the magnifying glass. I think that's helpful to actually see your normal curve. All right, we're going to find some probabilities now. So the first question is, what is the probability an individual owes at least $1,000? That means 1,000 or more dollars. That is a lot of college seniors. 1,000 or more, we want shaded. So we want the minimum to be 1,000 and see how that's what's shaded here. Your answer is this 0.98. That is the answer. But I would like you to calculate the z-score as well, and I can go over that with you guys in Google Meet if you have any questions. So the answer to number 1 for this question is 0.98. Question 2, what's the probability the senior owes more than 4,000? So we want to have shaded only from 4,000 and higher. So I'm going to change my minimum to 4,000. You're going to sketch and shade 4,000 and higher, and the answer is 0.25. 0.25. Number 3, the senior owns between 3,000 and 4,000. We're going to change our minimum to 3,000 and our maximum, oh shoot, I'll fix it. So our minimum is 3,000 and our maximum is 4,000. And our answer now is 0.34. So this is how you do normal distribution. It's such a great tool that you don't have to do those by hand and with the chart anymore. Okay, binomial distribution. Just to review, binomial, read these 4 things and study those. But this is an example of a binomial distribution. It does not say it's normally distributed, but we know this golf player is going to play 18 holes and the probability he gets a par is 0.3. So this distribution is called binomial. That's what you would type there. The N is 18 and the P is 0.3. To do this on Desmos, this is what you type in: binomial dist N, comma, P. So in Desmos, I'm going to get rid of this, and I'm going to type in binomial dist. And they even give you a hint when you use the parentheses. They want trials first. Well, he's going to play 18 rounds of golf, right? Or 18 holes of golf. And the success that he gets a par on any given hole is 0.3. All right. Now, these dots look all together. What we need to do is hit this magnifying glass again. So you guys kind of see it's like a right skewed distribution. The first question we're asked is, what's the probability of exactly 4.168? I already have the answer here, but let me show you how I got that. You can click on 4 and see the answer. You can also go to cumulative property, and we're interested in 4 through 4. We want exactly 4. So our answer is 0.168. Question C, at most 2. That means the most pars he gets is 2. So that means he's going to get 0 or 1 or 2 pars total. So we need to make sure we include 0, 1, and 2 on Desmos. So minimum is 0 par up to 2 par. And that adds up all 3 of these values. We'll call that 0.06. So the probability, or the answer, is 0.06, or you could say 6%. What's the probability? Again, when playing 18 holes, he gets at least 3. That'd be a great day. That means he would get 3 or more. So now we want to add up everything from 3 up to 18. 3 or more par. He'd be really happy. The chance of that happening is 0.94. So 0.94, or you could say 94%.